What is up, guys? Welcome to Bharden. My name is Heinrich, and today we're finally finishing off our archer enemy. So last time we just went about implementing all the states that we had already created for the other enemy, and so today we're going to create two new states specific for this enemy. So that would be our ranged attack state and our dodge state. Let's start off with our dodge state. So let's head back to Unity, and then we can go to our scripts folder, enemies folder, and then into our states folder. We can then go ahead and create a new C# script that we're going to call dodge state. We can then go into our data folder and create a d_dodge state C# script. So d_dodge state. And then finally, we can head to our enemy2 specific folder and create an e2_dodge state script. We can then just go ahead and open all three of these up. So there's our e2 dodge state. Then we need our dodge state itself. And finally, our data script. Now let's start off with getting our data script ready. So we can just go ahead and delete this code, make it inherit from scriptable object. And then let's go and open up a different data script, just so that we can get our create asset menu line. Paste that up there. And we'll change the file name to new dodge state. Same over here. Cool, so our data script is ready. Let's take a look at the dodge state itself. We can do the same thing and just get rid of this code. And this time we'll make it inherit from state. And then we can just go ahead and generate the constructor. Like that. And next we need to get a reference to our state data. So we have a protected d_dodge state called state data. Then we can just go ahead and add that to our constructor. So d_dodge state called state data. And then in the constructor we say this dot state data equals state data. And then next we can generate our function overrides. And we don't want the first three, like usual. Click OK. And there we go. So our dodge state is ready. So before we start adding anything to our dodge state, let's first think about what we want the dodge state to do. So let's go ahead and take a look at our state machine diagram so we can see what our conditions are. So as you can see from our player detected state, if our player is in close range, so our close action range, then we want to dodge. And so on our transition to our melee attack state, we have the condition that the player is in the close action range and we have already dodged. So the archer's first instinct when we get close is going to be to dodge. And then we'll have some sort of dodge cooldown timer. And if the player gets close enough again, the enemy will hit the player. Now, once we have dodged, if the player is in the close action range, then we're immediately going to punch the player. Otherwise, if the player is not in the close action range, but the enemy is still detecting the player, we're going to go into the ranged attack state. And then finally, if we dodge and we no longer detect the player, then we're going to go to the look for player state. So that should be simple enough. So let's go ahead and go back to our script. And we'll start off by declaring two booleans. These two booleans are going to keep track of whether the player is in the close action range or if they're in the max aggro range. So we'll start off with a protected bool called perform close range action. And then next we have a protected bool is player in max aggro range. Like that. Now we can just come to our doChecks function and add those two. So perform close range action is equal to entity dot check player in close range action. Like that. And then is player in max aggro range is equal to entity dot check player in max aggro range. Now for the dodge itself, we're going to use the same function we use for the knockback when the enemies get stunned. So that means we need to know when our enemy is grounded and we need to know when our dodge is over. So let's declare two more bools. The first one is going to be our is grounded. So we have protected bool is grounded. And then next we have a protected bool called isDodgeOver, like that. Now we can come to our doChecks function again and add our isGrounded. So isGrounded equals entity dot check ground, just like that. Then we need to come to our enter function and make sure we remember to set isDodgeOver to false. So isDodgeOver equals false. Next in our enter function, we want to set the dodge velocity. So before we can do that, we need to come to our d_dodgeState class and declare the variables that we need. So we'll start off by declaring a public float that is going to be our dodge speed. And then next we have a public vector2 that is our dodge angle. We also need two more floats that is going to be our dodge time, which is the same as our knockback time, just a little timer that makes it so that our isGround does not detect ground and stop our movement. So we have a public float called dodge time. And next we have our dodge cooldown. So we have a public float called dodge cooldown. And let's just set some default values. So for our dodge speed, let's set that equal to 10. And our dodge time is going to be 0.2. Dodge cooldown by default, we're going to set to 2. Perfect. Now we can come back to our dodge state. And then in our enter function, we can say entity dot set velocity. And remember, we have two set velocity functions, one that just takes in a single velocity value, and then one that takes in a velocity, angle, and direction. And so we're going to be using the second one, and we'll pass state data dot dodge speed as our velocity, state data dot dodge angle as our angle, and then finally our direction is going to be negative entity dot facing direction. Now in our logic update function, we're going to determine whether our enemy has dodged and is again touching the ground. So the dodge is over. So in our logic update function, we can say if time.time is greater than or equal to start time plus state data dot dodge time, and isGrounded is true. If this is the case, then we can say isDodgeOver equals true. And that's basically it for the dodge state, simple as that. So now before we take care of transitioning to our dodge state, let's go ahead and set up our enemy2 specific dodge state. So we can come to our e2 dodge state class, and then we can get rid of this code and make it inherit from dodge state. Next we can generate the constructor, and then set up our reference to our enemy2. So private enemy2 called enemy. And then in our constructor, we can just add that. So enemy2 enemy. And this dot enemy equals enemy. Then we can generate our function overrides. So quick actions, generate overrides. We don't want the first three. Click OK. And now we can set up our transitions. So in our logic update function, we'll start off by saying if isDodgeOver, because any of the transitions are only going to happen once the dodge is over. Then let's take a look at our finite state machine diagram. So we either want to transition to our melee attack state or our look for player state, because we don't have our ranged attack state yet. So we'll just put these two in for now. So when we go to our melee attack state, that means he's in the max range and he's in the perform close action range. So we'll say if is player in max aggro range and perform close range action, then state machine dot change state to enemy dot melee attack state. Else if, so in this case our player is not in our max aggro range. So else if not is player in max aggro range, then we want to say state machine dot change state to enemy dot look for player state. And if you want to, you can also make it so the enemy returns immediately when going into the look for player state. So maybe in the case where we dodged past him, he will turn immediately and look at us, but I'm just going to leave it as is. And that's basically all we need in here now. We just still need to add the transition to our range attack state. So let's leave ourselves a little to do. So we'll just say ranged attack state like that. Okay, now let's take care of the transitions into the dodge state. So if we look at the diagram again, we can see we only have one transition, and that is from our player detected state. So let's go ahead and go to our E2 player detected state. So in here, we're going to add some other if statements in our perform close range action if statement. So we want to set up the transition to our dodge state. Now this is supposed to happen if perform close range action is set to true, but we also want to transition to the melee state if our dodge cooldown has not yet reached 0. So in order to determine this, we need to get access to the start time of our states from different states. So let's actually go ahead and open up our state script, which is in our state machine folder, state. And as you can see, we have our protected float start time. So let's just set up a public getter and a private setter for this. So now this means that we can find out what a certain state's start time was from other states, which is going to come in really handy. So let's go back to our E2 player detected state. And then in our if perform close range action if statement, we'll say if time.time is greater than or equal to our enemy.dodge state, which we still haven't set up, dot start time. Like that. Now just to make sure this is correct, let's really go to enemy2. And let's go ahead and set up our dodge state. So first we need our public E2 underscore dodge state called dodge state. And this has a public getter and a private setter. And then we need the data. So serialize field private D underscore dodge state, call it dodge state data. And then we can call the constructor. So dodge state equals a new E2 underscore dodge state. We'll pass this as our entity, state machine as our state machine, dodge as our animation name, and then we have dodge state data as our data, and this as our enemy2. So back in E2 player detected state, this should work, but we still have an error on start time. Right, so we actually want to set it to public, and then instead of private set, it is protected set. Like that. Perfect. So back in our player detected state, yep, that works. So we can now access the start time of our dodge state from our player detected state. So we're going to use this as a reference to see when did we last start. So if our current time is greater than or equal to our last dodge time plus our cooldown, so we also need access to our dodge cooldown time. So let's go to our enemy2 class, and that is this dodge state data. So instead of private, let's just make that public and then give it a getter and a setter. So public get, private set. And then back in our player detected state, we should be able to say plus enemy dot dodge state data dot cooldown time. So if this is the case, then we want to dodge. So state machine dot change state to enemy dot dodge state. Else, so if our current time is not greater than that, we want to melee attack. So we can just put this in here. Okay, so it actually turns out that we can't use serialize field with our dodge state data like this. It won't show up in the inspector. So I'm not quite sure what to do to fix that yet. But for now, we can just leave it as public and then just get rid of this. This way we'll be able to access it from our state, but we can also set it in the inspector. I'll find out how to fix this and then update it in a future video. If you know how to fix this, please share in the comments. Okay, so let's head to Unity, and then we just need to create our dodge state data. So let's head to our enemy2 data folder. Then let's create a new data, state data, and we're creating the dodge state data. We'll just call it e2 underscore dodge state data. And as you can see, everything is set up for us except for our dodge angle, which we'll just leave as 1 on the X and 2 on the Y. Actually, no, I'm wrong. We'll leave it as 2 on the X and 1 on the Y to give our enemy some more distance. Then let's come to our enemy2 game object and drag that in. Boop, just like that. And then we just need to set up the animations. So let's open up our animator and see what we have going on. Make sure we click on our alive game object. So let's start off by creating our Boolean parameter, which is just dodge. Drag that up. And if you remember correctly, we made these 3 animations for our dodge. So our dodge start, dodge up, and dodge down. So let's drag up our dodge start animation. Just put it around here. And let's make a transition from empty to that animation. We can click on it, make sure has exit time is not ticked, and then set the transition duration to 0. Our condition is dodge is true. So when we dodge, we're going to come into this animation and we're going to let it play completely before going into a blend tree with these 2 animations. So we can actually delete these 2 and then come and create a new state that's going to be a new blend tree. And we can just call this our dodge blend tree. From our dodge start animation, let's make a transition down to our blend tree. And in this case, has exit time should be ticked, and we should set the exit time to 1. This means our dodge start animation is going to play all the way before we transition to our blend tree. We can also just set the transition duration to 0. Seeing as we have an exit time, we don't require a condition for this. Now go ahead and double click on the blend tree. Click on the blend tree in the middle, and here we have our list of motions. That's just the different animations we want to play. So let's hit the plus icon and create a new motion field. And we can do that twice because we have 2 animations. And then let's just navigate to our animations folder. Then into our enemies folder. And I see here I still have my enemy1 animations. So let's just drag those into the enemy1 folder. And then in our enemy2 folder, here we have our dodge down and our dodge up animations. So in our blend tree, let's drag those 2 in. So dodge down, dodge up. Might just have to move them around. So as you can see, we have a blend type that is 1D. So we have one variable that's going to control these animations. Now, in order to determine which of these animations need to play, we need to know the Y velocity of our enemy. So as you can see under our parameters, it added a blend float parameter for us. So we can just go ahead and click on that and rename it to Y velocity. Like that. And now we can use our Y velocity to control which animation plays. We just need to go to our entity script and pass in our Y velocity first. But for now, let's finish setting this up. So as you can see, if our Y velocity is 0, we're playing enemy2 dodge down. This is not quite right. We want to come to the inspector and untick automate threshold. And then we're going to set the threshold for dodge down to -1. So now, if our velocity is -1, then the dodge down animation is going to play. So any Y velocity less than or equal to -1 will result in dodge down. Then as we go up, as you can see, once we get to 0, so actually anything lower than 0 is going to play dodge down. Anything greater than 0 is going to play dodge up. Perfect. We can then come out of our blend tree by clicking on base layer up here. And now we can set the transition back to empty. This transition is going to come from our blend tree. So make a transition from there to empty. Click on it. Has exit time is not ticked. Transition duration is 0. And the condition is that dodge is false. Now we just need to go to our entity script and pass our Y velocity to the parameter. So let's go to our scripts and then go to the entity.cs script. Then in our update function over here, we can just say anim.setFloat, and the float name that we want to set is going to be Y velocity. And we'll just have to go back to our enemy1 and also add this parameter to the animator if we don't want to get any errors. And the value we want to set it to is our rigidbody.velocity.y. So let's go back to Unity and let's go to enemy1 alive. Let's add a float parameter, and we'll just call it y velocity. Now it's going to be very important that we always spell it the same way in all of our enemies. But that should be good. Let's test it out. So on our enemy 2, if we get closer than this circle over here, our enemy should dodge. Let's see what happens. See if it works. Oh, he tried to punch me. Looks like he did dodge. Yeah, he does dodge, but it's not quite right yet. I think we have to increase our dodge speed. So it looks like he's not going up high enough, and then the dodge time is still affecting whether or not he stops. So let's click on enemy 2, go to our dodge state data, and let's change the dodge speed to 30. Let's try that one out. That might be a little bit too much, but it works. Let's try 15 maybe. It's a little bit better. I don't like that he's bouncing like that though. Okay, so he's currently detecting us. As you can see, if we get close after he dodges, he tries to punch us instead. But why is he bouncing like that? Maybe let's just keep his dodge angle at 1-1. I also think his dodge distance, or his close range action distance, is a little bit too close. So let's go ahead and go to our base data. And this is our close range action distance. Let's just increase that slightly. Put it around there, so where he will still get damaged when we punch. I like it. Perfect, so our dodge is working. Now, if we don't want him to dodge off of ledges, it's as simple and as complicated as just checking behind the enemy to see if there's a ledge. It's easy enough if he's right on the edge to see, okay, there's no ledge there, so don't dodge. But we might want to set up something where we can determine how far back the enemy is going to dodge, and then at that point check and see if there's ground, and then only if there is ground, then dodge back. But I haven't quite figured this out yet, but it is something I'm going to add to this enemy. But we're in good shape. So I think now we can head on to our ranged attack. So once our enemy detects our player, if we don't get within our close action range and our action time is over, we're going to shoot an arrow at the player. Then once we've shot the arrow, if the player is still within the max aggro range, we're going to go back to player detected. Else, if we don't see the player, we're going to go to look for player. So let's go ahead and go back to Unity, and then let's head to our enemies folder, states folder, and let's create a new C# script that we're going to call ranged attack state. Like that. We can also go to the data folder and create a d_ranged attack state. And then we can go to our enemy 2 specific folder and create our ranged attack state there. So e2_ranged attack state. We can go ahead and open all of those up. So we have that one, this one, and this one. Perfect. Again, let's just start with our data script and go ahead and delete all of this code, make it inherit from scriptable object. And then we can just come and copy this again. Throw it on there, and now instead of new dodge state data, it's going to be new ranged attack state data. Like that, and that's good. Next we can come to our ranged attack state, get rid of this code, and then make it inherit from attack state. Now remember, with our melee attack, instead of having a melee attack that inherits from state, we created another state called attack state that is just a general combat state, and then our different types of attack inherit from that instead. So melee attack and ranged attack both inherit from attack state. The attack state then takes care of all the general things. So we're really not going to do a lot in this state. The first thing we need to add is our constructor. So let's go ahead and generate that. And then we need to get a reference to our state data. So we have a protected d_ranged attack state, and we're just calling it state data. Then in the constructor, we say d_ranged attack state called state data. And then in the constructor, this dot state data equals state data. Like that. Then we can go ahead and generate the function overrides. We don't want the first three. Click OK, and perfect. Now let's just go ahead and bring up our attack state. So as you can see, our attack state takes care of keeping track of our player, so we don't have to do that. It sets up all of our interactions with the other script, sets the velocity to 0, and sets our is animation finished equal to true. So all we need to do in our range attack state is spawn the projectile on the attack transform, or the attack position. So let's go ahead and go to our d_ranged attack. The first thing we're going to need is our projectile. So we'll have a public game object that's going to store the projectile prefab. Then next we need to know how much damage our projectile is going to do. So we have a public float called projectile damage. Then next we need to have the speed that our projectile moves at. So public float projectile speed. And then finally we need to have our projectile travel distance. The reason we need this is because it's a platformer. I want the arrow to move in a straight line for a certain distance and then start getting affected by gravity and falling down. So this projectile travel distance is going to be how far does the projectile travel before it starts getting affected by gravity. So we have a public float projectile travel distance. Now you could also set up all these variables on the projectile itself, but I'm going to keep these things like attack specific, and I'm going to have a different state for all the different attacks. So if my enemy ends up having multiple ranged attacks, it's going to have a different range attack state for each one. So by default, let's just set our projectile damage to 10 and our projectile speed to 12. Like that. Now I said in our ranged attack state, the only thing we need to do is instantiate our projectile. Now when we instantiate our projectile, we need to take all of these variables and pass it to our projectile. But before we can do that, we need to set up our projectile. So let's go back to Unity, and then let's go to our scripts folder, and let's just create a new folder called projectiles. In this folder, let's create a new C# script, and this script we're just going to call projectile as well. Now I'm considering maybe in the future adding magic and different types of projectiles to the game, so we're probably going to end up using some sort of inheritance system for that as well. But for now, we'll just leave this projectile script super basic. It's just a once-off script, and we can build on it in the future. Now let's create an empty game object that is going to be our arrow. We'll just call it arrow, and don't forget to reset the transform. And now before we can add a sprite to it, we actually need to import that. So let's go to our sprites folder, and I've included the projectile sprites in the description. So we'll just create a new folder called projectiles again. Go ahead and open that up, and then just import your arrows. You can go ahead and click on that and set the pixels per unit to 16. The sprite mode is multiple. Filter mode is point no filter, and compression is none. Hit apply, and then let's open up the Sprite Editor. Now I've included 2 arrow sprites that I drew. You can use whichever one you like. I'm going to use the one on the right. So we'll say slice, grid by cell size, and the pixel size is 32 by 32. Go ahead and hit slice, and now we have our 2 arrows. Then hit apply, and we're good. Now let's click on our arrow game object, and let's go ahead and add our Sprite Renderer. We can open that up, and then let's just drag in the sprite that we want to use. If you don't see it, don't forget to come to the sorting layer and change that to enemy. Also make sure you're actually looking at it. We might end up making a projectile layer later, but for now we'll just keep it on the enemy layer. Perfect. Next, we need to add a Rigidbody 2D component to our arrow. And let's just open that up and set the collision detection to continuous. We can set the gravity scale to 8, but we might mess around with this later depending on how fast we want the arrow to drop down to the ground. And I think that's everything we need for now, so let's go ahead and go back to our code. Now our projectile is going to interact with our player the same way any attack does, by using our attack details and sending a message to whatever it hits. So let's go ahead and get rid of this code and start off by declaring a attack details variable. So we have a private attack details called attack details, and that's just going to store everything we need. Next, we need to have the speed of our projectiles. So we have private float speed, and then we also need to have a reference to our Rigidbody so that we can apply that speed. So we have a private Rigidbody 2D called RB. So now we can go ahead and call our start function. And in the start function, let's start off by saying Rigidbody equals getComponent of type Rigidbody 2D. And then let's immediately set our gravity scale to 0. So rb.gravity scale equals 0.0f. Then we can move our projectile by saying Rigidbody.velocity equals transform.right multiplied with our speed. Now, as I mentioned earlier, we want the projectile to travel a certain amount of distance before falling down to the ground. So we need to come up and declare our private float travel distance. And then we also have to declare a private float x start position. So once we instantiate the projectile, it's going to say, okay, this is my x position, and then it's going to use this position with our travel distance to determine when to turn on gravity. So let's come to start and say x start position equals transform.position.x. Now let's go ahead and create our fixed update function. And in our fixed update function, we can say if mathf.abs, so the absolute value of our x start position minus transform.position.x is greater than or equal to our travel distance. So the mathf.abs accounts for traveling left or right. So if this is greater than our travel distance, then we want to turn on our gravity. So let's actually go up and declare a Boolean that's going to keep track of if our gravity is currently on or not. So we'll have a private bool called isGravity on. And then in our start function, we'll just make sure that is false. So isGravity on equals false. Then in this function, we can say isGravity on equals true. Now we also want to make sure this only gets called once, so let's add that as a condition to our if statement and say, and isGravity on does not equal true. So not isGravity on. So now we're turning on gravity, meaning we have to set our gravity scale to something. So let's come back up to our variables and let's declare another private float, but this time it's going to be a serialized field, private float gravity. Then back in our if statement, we'll just say Rigidbody.gravityScale equals gravity. Now, once we've fired the arrow, we have two options. The arrow can either hit the player or it can hit the ground. So we need to be detecting both of these. So let's come up to our variables and let's create two layer masks. So we'll have a serialized field, private layer mask called whatisGround. And then we have another serialized field, private layer mask, whatisPlayer. So this means on our projectile, we need to be detecting this using some sort of physics thing. So we're going to set up a damaged position on our arrowhead. So we'll have another serialized field. This time it's a private transform that we'll just call damage position. And while we're at it, let's also create another private boolean that's going to be called has hit ground. And we're going to use this has hit ground to basically turn off the projectile once we hit ground, so it can no longer damage the player if we walk over it. So let's come back down to our fixed update function, and let's just create another if statement, and inside the if statement we'll say not has hit ground. And then let's just move this if statement into here, like that. And now before this happens, so in our if not has hit ground, let's do the collider checks. So we'll declare a collider 2D that we'll call damage hit, and we'll just set it equal to physics2d dot overlap circle. And now for our overlap circle, we need a position and a radius. So we actually need to come up and declare a damage radius. So we have another serialized field, private float, that we call damage radius. And then back in the function, we can say damage position dot position damage radius as our radius. And then finally, we pass it what is player as our layer mask. Now we'll create another collider 2D that we'll call ground hit. And we'll set this equal to physics2d dot overlap circle. And again, we'll use damage position as our position, damage radius as our radius, and then for our layer mask, we use what is ground. Now after this, we can say if damage hit, so we have detected something, in this case our player, then we want to say damage hit dot transform dot send message. So it says take the object that we hit and send it a message, and the message we want to send is damage, and the parameters we want to pass is our attack details, like that. Then after we hit the enemy, we want to destroy the arrow. So we'll say destroy game object. Now in the case where we hit the ground, so if ground hit, then we want to say has hit ground equals true. Then we're going to set the gravity scale of the arrow back to 0 so it doesn't keep falling. So rigidbody dot gravity scale equals 0. And then finally we want to set the velocity to 0. So rigidbody dot velocity equals vector2 dot 0. And that's perfect. Now let's just go ahead and call our onDrawGizmos function so that we can draw our damage position just so we can see where it is. So let's come down to the bottom and say onDrawGizmos. And then in this, we just want to say gizmos.draw wire sphere. And the parameters for this is going to be our damage position.position and our damage radius. Now the last thing we want to do is make sure when gravity is enabled that our arrow is going to rotate in the direction that it's falling. This we're going to do in our update function. So let's just go ahead and call update. And then in the function, all we have to say is if not has hit ground, then if is gravity on, so we only want to rotate it once gravity is on, we're going to say float angle equals mathf dot atan2. And so what atan2 does is it just returns an angle between two lines. So if we have a triangle and one side is going to be our x velocity and the other side is our y velocity, then it's going to return this angle. So for our float y, we pass rigidbody.velocity.y, and for our x, we pass rigidbody.velocity.x. Now atan2 does return this in radians, so we have to convert it back to degrees, and that's as simple as multiplying it with mathf.radians to degrees. Now that we know the angle that we want to rotate the arrow, we just have to rotate it with transform.rotation equals quaternion dot angle axis. And what dot angle axis does is it creates a rotation which rotates our angle degrees, which we pass to it, around a certain axis. So to this, we're going to pass our angle, and as our axis is going to be vector3 dot forward. So vector3 dot forward is basically pointing into the screen, and that's the axis we want to rotate around, just like that. Now the reason we have this in two separate if statements is because before we do this, we need to update our attack details x position. So before this if statement, let's come and say attack details dot position equals transform dot position, like that. And now we're basically done with our projectile script. The last thing we need to do is just create a function in this script that sets up everything once we spawn the projectile. So let's come down to the bottom and let's create a new public void function this time. Public because we want to call it from different scripts, and we'll just call it fire projectile. And as parameters to this function, we're going to take in the speed of the projectile. Oops. So we have a float speed, then we have a float travel distance, and then finally we want to pass in the amount of damage the projectile does. So float damage. Like that. Now in this function, we just say this dot speed equals speed, and this dot travel distance equals travel distance, and finally attack details dot damage amount equals damage. Just like that. And we're basically done with the projectile script. So let's go back to Unity and let's throw that script on here. So we can go back to our scripts folder, projectiles, and then click on our arrow game object and just drag this on. Simple as that. Now for the gravity, let's just set that to 3 to start off with. Can't set the damage radius yet. What is ground is ground. What is player is player. And then let's create a child game object that is going to be our damage transform or damage position. Let's go ahead and drag that in. And now if we set a damage radius, we should be able to start seeing it. So let's just make it 0.15 and then position it at the tip of the arrow, like that. Perfect. Now let's go to our prefabs folder and let's make a prefab out of the arrow. We can then go ahead and delete it from our scene. And now we're ready to set it up in the enemy to actually spawn the arrow. Okay, so now let's go back to our ranged attack state. So here, and then let's spawn our projectile. So in our trigger attack function, which is going to get triggered by our ranged attack, we can say GameObject.instantiate. And remember, we have to say GameObject.instantiate this time because we are not inheriting from monoBehavior. And to this function, we're just going to pass stateData.projectile. Then we want to pass our attack position.position. And then finally, we want to pass it our attack position.rotation as the rotation. So now in order to be able to call this fire projectile function from our ranged attack state script, we need to get access to it. So let's come up to our variables and let's declare a protected game object that will call projectile. And then let's also declare a protected projectile called projectile script. Like that. Then let's come back to our trigger attack and we'll set projectile equal to our GameObject.instantiate. Like that. And then after that, we can say projectile script equals projectile.getComponent of type projectile. And then finally, we can say projectile script dot fire projectile, and we're going to pass our state data dot projectile speed as our speed, state data dot projectile travel distance as our travel distance, and then finally state data dot projectile damage as our damage, just like that. Now all that we need to do in our E2 ranged attack state is set up our transitions. So if we head over here, get rid of this code, and then make it inherit from ranged attack state, we can then generate the constructor, and then get the reference to our enemy2. So private enemy2, enemy, add that to the constructor. So enemy2, enemy, and then we can say this dot enemy equals enemy. And then finally we can just generate the function overrides. Like that. Now let's go to our logic update function, and then let's take a look at our finite state machine diagram. So from our range attack state, we're only going to transition to our player detected state or our look for player state. So back in our script, we can just say if is animation finished, so our fire animation has stopped playing, then if is player in min aggro range, then we want to transition to our player detected state, so state machine dot change state to enemy dot player detected state. Else we want to transition to our look for player state, so state machine dot change state to enemy dot look for player state. And that's all we need in here. So now let's head to our enemy2 script and create the attack state. So we'll have another public E2 underscore ranged attack state. Call it range attack state. Ranged attack state. Create the public getter and the private setter. Then we need the state data, so serialize field, private d underscore ranged attack state. Call it ranged attack state data. And then we can call the constructor. So ranged attack state equals a new E2 underscore ranged attack state. This is our entity. State machine is our state machine. Our animation boolean name is just going to be ranged attack. Then we pass our ranged attack state data as our data, and then finally this as our enemy2. And I forgot we also have to set up a transform for it. So let's come up here and declare another serialize field, private transform, that will just call ranged attack position. And then back in the constructor, it comes after our animation boolean name. So over here, ranged attack position, like that. Perfect. So now let's go back to Unity and set everything up. As you can see, we need our data and our transform. So let's start off with the transform. Click on the alive game object and create a new empty child. Call it ranged attack position. And then let's also navigate to our enemy2 data folder and create a new data, state data, ranged attack state data. And then we'll just call it E2 underscore ranged attack state data. While we're here, we might as well lock the inspector and go to our prefabs folder and drag in our arrow. I also see I forgot to set the projectile travel distance default variable. So let's just go ahead and set that to, let's say about 8. So it's going to go 8 units before it starts falling. We can then click back on our enemy2 game object, unlock our inspector, and then drag in our ranged attack position, and then also our data. Now let's click on our alive game object and go to our animation window, and let's look at our ranged attack animation. So here is where we shoot the arrow. So we want to instantiate the arrow around here. So let's just move our ranged attack position over there. And then also, while we're in the animation, we need to remember to add our animation event. The function we want to call is our trigger attack function. And then at the end of our animation, we want to add another animation event and call our finish attack animation. Now all we have left to do is to set up our animator. So let's go to our animator window. And as you can see, our range attack animation is the only one we have left. And let's just put that over here. Now we just have to add our Boolean parameter, which is ranged attack. We can drag that up to the top. And then let's make a transition from empty to our ranged attack. Click on it. Has exit time is false. Our transition duration is 0. And then the condition is ranged attack is true. Then we have a transition going back to empty. Has exit time is false. The transition duration is 0. And the condition is that ranged attack is false. Everything should be set up now. Let's give it a try and see what we forgot. So actually, I think we need to mess with these things a little bit. So let's click on our enemy2 game object and let's just move it back over here. So let's say when the enemy's all the way over here and I stand over here, I want him to detect me and shoot at me. So let's click on our enemy base data and let's increase our max aggro range to about there. So let's make it 8.5. And then let's just make our min aggro distance 7.5, something like that. Let's also make our max health 40. That way we can actually stun our enemy. And then we should go to our enemy2 game object again. Click on our player detected state data. So this is how long we have to wait before he actually shoots us. Let's just make it 1 second. Okay, let's see how it works. So if we jump up over here, he's gonna wait a second and he should shoot us, except not really, because I forgot to set up the transitions like a dummy. Okay, so if we look at the state diagram, we have transitions from player detected and from our dodge state into our ranged attack state. We also have one coming from our damage function if we are in range but we're not close. So let's set those up. So let's start off with our E2 player detected state. And then in our logic update function, after our first if statement, we want to come and say else if perform long range action. So that means our long range action time is less than 0. Then state machine dot change state to enemy dot range attack state. Next, we need to go to our E2 dodge state. So in here, we just want to come after our first if and say else if is player in max aggro range and not perform close range action. So that means our enemy is still detecting our player, but he's not close enough to punch or to dodge. Then we want to go into the range attack state. So state machine dot change state to enemy dot range attack state. Now the last thing we have left to do is our damage function. So let's go to our enemy2 class, and then in our damage function, we can add an else if before our last else if, saying else if check player in min aggro range, then state machine dot change state to ranged attack state. Like that. Okay, everything should work now. Fingers crossed. So if we get in front of him, he's going to detect us and then shoot at us. Perfect. And then if we dodge the arrow, it'll stick to the ground like that. Okay. So this is why we would want to make a projectile layer so that we can put it behind our platforms. But whatever works for you. And now another thing I should mention is, as you can see, when he detects us, he just gets stiff like that. And that is because I forgot to add the idle animations to those animation states. So in our look for player state, as you can see, our motion is none. So that means he's just going to show that default sprite. So we can click on the little circle over here, which opens up this menu. And we can just go and find our enemy2 idle animation. And we need to do the same thing in our player detected state. So click there, enemy2 idle. And that's basically it. So we now have an enemy that walks around. If he sees us, he's going to shoot at us. If we get too close, he dodges back. If we get too close, he punches us. Beautiful. Okay, I'm so excited about this. Let's see if we can stun him, make sure that works. you get stunned, and he dies. Everything is working so well, and I'm so excited. Now again, there's still lots of things we can do to improve these enemies, and I hope you guys saw how I go about adding the transitions and planning them out and things like that, and I hope you guys managed to make your own transitions for your own enemies and expand upon this system. There's still a lot of things I want to do. The way the enemies detect the player is not always the best, seeing as we're using just a single ray, so sometimes if we're in front of him and we jump, he will no longer detect us. So I'm going to experiment with using some box colliders and things like that, and then when I come up with a better system, of course, I'm going to share it with you guys once again. But for now, I think we're at a good place to leave off with our more complex enemy behaviors. I think it's about time we move on to some different parts of the game, and then we can come back and iterate upon this later. So yeah, I hope you guys had fun with that. Now, something absolutely amazing happened within the last couple of days, and that is that Bharden has hit 2,000 subscribers, which is absolutely insane because my original goal for this channel was to hit 1,000 subscribers by the time that I graduate, which is in a little less than a year. And so that means I've hit double my goal with a year to spare, and it's absolutely amazing, and it's all because of you guys. You guys have been so supportive of my work, and it absolutely warms my heart, and I'm so grateful to each and every one of you. Now, I've been thinking of ways that we could celebrate this, but I haven't really come up with anything good. I don't really know how one goes about celebrating this, but I want to do something to say thank you to you guys. So if you guys have any suggestions of things that we can do to celebrate hitting 2,000 subscribers, please let me know in the comments. Come onto Discord and we can chat about it, and I'm excited to hear your ideas, and then yeah, we'll see what we do. So once again, thank you to each and every single one of you. I really appreciate it. Now, before I go, of course, I would just like to give a huge thank you to all of my supporters and wonderful people over on Patreon, and an absolutely massive thank you to Gregory, Miguel, and Yupa for your support on Patreon. You guys are absolute mad lads. And yeah, I hope you guys all have a wonderful day.